All right, so comparing two proportions. So basically, just like in short, we are going to compare two groups. They're independent groups. Then we want to know, do they differ? By how much? And then, is the difference great enough so that it is unlikely to be due to natural sampling variation? All right, so a consumer magazine plans to poll car owners to see if they're all happy enough with their vehicles that they would purchase the same model again. They'll randomly select 450 owners of American-made cars and 450 owners of Japanese models. Obviously, the actual opinions of the entire population couldn't be known, but suppose 76% of owners of American cars and 78% of Japanese cars would purchase another. So first, what sampling design is this magazine planning to use? Just have to think back to a throwback. Yeah.
I would just say that 70%. I know that's not right.
There's something before it, but that's part of it.
Oh, it's the multi thing.
Sort of, yeah. It's just like saying the names together, but yeah, technically, I guess it's multi. Do you remember what it was when we were like grouping differently? What we called that?
Stratified.
Mm-hmm. Yep, stratified, simple, random sample. So it's first stratified by country of origin. Of the car, then a simple random sample. And then what difference would you expect their poll to show? So that's like just simple math. So what's the difference in those two numbers?
What am I looking at?
The percentage, yeah.
2.
Yep, so 2%. Because that's the difference in percentage. So, of course, sampling error means the poll won't reflect the difference perfectly. What's the standard deviation for the difference of the proportion? So this is where we use the formula we got yesterday. That's the square root of P1 hat Q1 hat over N1 plus P2 hat Q2 hat over N2. So this is, let's see, 0.76 times 0.24 divided by, let's see, that's for American, and American was 450. I guess they're both 450. Plus 0.78 times 0.22 divided by 450. And that comes out to be 0.028. So then for the sketch a sampling model for the difference in proportions that might appear in a poll like this, we're basically just using the empirical rule for this. So we're solving out 3 standard deviations away. So we have the 2%, that was the difference originally, so 0.02, and then we just add the 0.028, so 0.048, 0.076, and 0.104. And then in the other direction, minus 0.008, minus 0.036, and minus 0.064. And so then in here we have the 68, 95, and then 99.7. So then, could the magazine be misled by the poll, concluding that owners of American cars are much happier with their vehicles than owners of Japanese cars? So yes, because of these negative proportions. Because they indicate owners of American cars are happier than owners of Japanese cars. And the negatives are less than 2 standard deviations from the mean, which was 2%. So if it had been like out here before we had a negative, we wouldn't worry about it, but since they were up here 1 and 2 standard deviations away, we do care about it. So in 2007, a Pew survey asked 1,447 internet users about their source of news and information about science. Among those who had broadband access at home, 34% said they would turn to the internet for most of their science news. The report on this survey claims that it is not significantly different from the percentage 33% who said that they ordinarily get their science news from television. What does it mean to say that the difference is not significant? So this would say that the difference between those who have broadband and those who do not is not large enough. This difference could have been the result of natural sampling variation. So there's really only like a 1% difference in those. Huh? What do you mean?
Like, where can I go to see a lesson report? You know what I'm talking
No.
about? So like, if I want to, so say like I'm struggling with something, with a chapter, and I want to go back to the lesson report.
Oh. I thought you meant about the question. Oh, it's on YouTube. I was like, what? I was like, how is that relevant to this question? Okay. All right. In October of 2000, the U.S. Department of Commerce reported the results of a large-scale survey on high school graduation. Researchers contacted more than 25,000 Americans aged 24 years to see if they had finished high school. 84.9% of the 12,460 males and 88.1% of the 12,678 females indicated that they had a high school diploma. Are assumptions and conditions necessary for inference satisfied? So, yes. It's independent, 10%. Certainly more than 10 when we multiply the numbers, all that fun
I
stuff.
haven't been like none of the condition, but like not none of the condition, like a condition or two is
Then we can't perform the,
solid.
yeah. Which is why, like, most of the time, it's going to be rare that the conditions aren't met. Unless it's a question specifically asking, like, exclusively are the conditions met? Like, those questions. But if they're asking you to actually go, like, if they're going through all this to tell you to solve something, they're going to be met. Or, like, sometimes we have the ones that, like, there's an alternative, like, it doesn't have to be, like, the one, it was a couple chapters ago, but, like, it didn't have to be independent if it was, like, 10%, like that. Or, like, And sometimes you're making some assumptions, too, which is fine. So, create a 95% confidence interval for the difference in graduation rates between males and females. So, this is females minus males. So, our confidence interval, which we can do with the calculator, but I will show you by hand what it is, and then I'll show you the calculator. we have female, so 0.881 minus 0.849 for male. Plus or minus, the confidence level for 95% is 1.96. And then the square root of, and then it's the standard error. So it's the standard error for this chapter, which is the P1 hat, Q1 hat over N1 plus the P2, Q2 over N2. So 0.881 times 0.119 divided by 12,678 plus 0.849 times 0.151 over 12,460. And then you could actually get your range, like your two numbers from that, one by adding and one by subtracting. Or you can do the 2 prop z interval on your calculator. So I'll give you the calculator to do that. I just need to find the thing. 2 prop z interval. And that's under test. You just have to scroll down way farther than normal. But then you plug in all this stuff. It'll ask you for each thing and then for your confidence level. No, that's a different problem. You may actually have to find the percentages for those. So you may have to do like 84.9% of this number to plug in your X1 and your X2. Because like this, so like this would be, well, women first. So this would be N1, this would be N2. So to get X1, it's this percentage of this number. So you would have to do 0.881 times 12,678. And then it's going to have to be rounded to the nearest whole number. But you probably can multiply it within that without, like, in the function. So what did that give you? 11,669. And then it should ask you the same thing for X2. And then you just have to put in your N2, and then I think it asks for your confidence level, which in this case they told us what they want. Yeah. So that would be your interval for 95% confidence. So then to interpret that, we're taking those numbers and we're just explaining what this range means. So, and if you had flipped N1 and N, or like the N's and, or like the 1 and the 2, your numbers would just be backwards. That's the only difference. So based on the sample, I am 95% confident that 2.4% to 4% guess that's 2.3% actually. Let's just round to 4% more females have graduated high school than males. And then, does this provide strong evidence that girls are more likely than boys to complete high school? So, this interval is completely above 0, so there's none of it that's negative. So this interval is entirely above 0, suggesting that girls are more likely to graduate high school among 24-year-olds. And that's just because that's who they were surveying, not saying like 24-year-olds are graduating from high school. There's just one more, so I think we can go ahead and do it. It's 2 pages, but it's not actually that long. Yeah, but it's not actually that long. The longest part is either part C or H. It's only 3 lines. Like, it's not bad. All right, so the Journal of the American Medical Association reported on an experiment intended to see if the drug Prozac could be used as a treatment for an eating disorder, anorexia nervosa. The subjects, women being treated for anorexia, were randomly divided into 2 groups. Of the 49 who received Prozac, 35 were deemed healthy a year later, compared to the 32 of the 44 who got the placebo. So, are the conditions for inference satisfied? Yes, we're going to assume that they're met. So, again, I could do this next question by hand the same way using that formula that we just used in the last problem to compare the 2 things, or you can just use the calculator. So, we'll just use the calculator for this one. So we're going to use the 2 prop Z interval to find our confidence interval. So the 2 prop Z interval for X1, so we're just going to say that they received the Prozac is going to be 1, and then the other is going to be 2. So it'll be 35, 49, and then the placebo 32, 44, and then our confidence interval of 0.95. So then, use your confidence interval to explain whether you think Prozac is effective. So, for it to be effective, we would want our entire interval to be above 0. But 0 is included in our interval because we have a negative. So 0 is falling somewhere in here. I mean, generally speaking, almost exactly in the middle. So, no, the confidence interval doesn't show Prozac is effective since 0 is included. Some samples may show that Prozac and the placebo are equally effective.
Isn't a placebo the thing that's in your backyard?
In your backyard?
That's a cousin.
No, a placebo is like a sugar pill. So you like think you're getting the treatment, but you're really not.
Okay. I always used to get those two mixed up.
Gazebo, placebo, yeah, it's basically the same thing. So suppose instead of constructing an interval, you conduct a hypothesis test. What hypothesis would you test? So the null would be what?
I don't know. Well, it's Prozac is. Oh wait, hold on. This is
You're right.
P
So P of Prozac is equal to what?
placebo.
P of placebo. So that's the null, is that there's no change. The alternate, okay, what are we trying to show?
If Prozac is greater than placebo.
Yep. So P of Prozac greater than P of placebo. So then state a conclusion based on your confidence interval. So that confidence interval is obviously given to us. So we need to decide if we're rejecting or failing to reject. The null hypothesis. So from that, so from our interval, we are going to fail to reject the null hypothesis because, again, 0 is included. So there is not enough evidence to suggest Prozac works better. So then what alpha level did we use since our confidence level was 95%? What was our alpha?
I swear I forgot.
So alpha is the difference between the confidence interval and 100.
So it's 100 minus 1.64.
No. The confidence interval. So like we had a 95% confidence interval.
So it's 100.
So 100 minus 95.
Oh,
Or in this case it'll be 0.05. So we had 100 minus 95. Because our confidence level was 95%. So then, but we only cared about the greater than, means we only look at half of it. So we need to actually cut this in half. So our alpha is equal to 0.025 because it was a one-tail test. So then, if that conclusion is wrong, which type of error did you make? Was it a type 1 or a type 2?
type 1. Which one's the false negative? It's type 2.
Yeah. So, so a type 2 error because we failed to reject, but we should have rejected. Because the null was false. So what would the consequences of such an error be? So basically this would say that we think Prozac is not effective. But it is. So we missed the opportunity to treat the women with anorexia.